about tangent lines and velocities. And so the definition of a tangent line is a line that touches the curve and should have the same direction as the curve at the point of contact. Now the old or previous definition of tangent that we have learned of is the Euclidean tangent, which says that a tangent line only intersects the circle once. But this is no longer true because, as we can see with the second function, the tangent line goes through the function twice, once at the point of tangency and once more through a different point. And so a tangent line can pass through the function multiple times, but it is only tangent when it touches the curve once. And so to solve for the tangent line, we have an example here where the function is y equals x squared, and we have 2 points, point P and Q. And so we want to find the slope of the tangent line at P. So what we know to do first is to find the slope between P and Q. And so if P is C comma f of C, and the difference between P and Q of the x value is delta x, then the point of Q is C plus delta x comma f of C plus delta x. Now, we know that the slope is y2 minus y1 over x2 minus x1. So to find the slope between P and Q, we can just plug that in and we'll get f of C plus delta x minus f of C over C plus delta x minus C, which will equal f of C plus delta x minus f of C plus delta x. And so if we want to find the slope at P, which is the of the tangent line, which is the red line in the picture, then we want to get that delta x to be super, super small, so that the closer and closer P and Q are, the more accurate. So if we make that a limit, and so the limit as delta x goes to 0, so that delta x gets smaller and smaller and smaller, we'll get that the slope of the tangent line at point P, which is C comma f of C, will be the limit as delta x goes to 0 of f of C plus delta x minus f of C over delta x. Now, let's do an example. So, the question is, find the equation of a tangent line using the limit process of f of x equals x plus x squared at point P, which is going to be 3 comma 12. Now, we know that the limit definition is that the limit as delta x goes to 0 is f of x plus delta x minus f of x plus delta x. Now let's plug in what we know, and the limit of delta x goes to 0 is f of 3 plus delta x, because 3 is our x value, minus f of 3 over delta x. Now plugging in f of 3 plus delta x into the equation, we'll get the limit as delta x goes to 0 is 3 plus delta x plus 3 plus delta x squared, and then f of 3 is just going to be 12, and that's all over delta x. Now if we further solve, we'll get 3 plus delta x plus 9 plus 6 delta x plus delta x squared minus 12 over delta x. Now if we reduce that a little bit, we'll get the limit of delta x goes to 0 is 12 plus 7 delta x plus delta x squared minus 12 over delta x. Now we can cancel the 12s, because 12 minus 12 is 0, and then we'll get, and we can also factor out a delta x, and we'll get the limit as delta x goes to 0 is delta x times 7 plus delta x over delta x. Now we can cancel out the delta x because there's one in the numerator and the denominator, and so the limit as delta x goes to 0 is 7 plus delta x. So plugging in delta x as 0, we will get 7. Now to find the equation, we can plug in the points we know and the slope in the point slope form, which is y minus y1 equals m times x minus 1. And so y minus 12 equals 7 times x minus 3, because we know that y1 and x1 are the point that we're looking for, which is 3 comma 12, and the m is the slope that we just solved for using the limit definition. And so if we solve for y, we get y equals 7x minus 9, which is the equation of the tangent line at point 3 comma 12.
Let's look at average velocity. Velocity is speed with direction. which is distance over time. The graph depicts velocity as distance is the y-axis and time is the x-axis. To find the average velocity, we need the change of distance over change of time. In other words, the change of y over change of x. If we want to find the average velocity between time equals 6 and time equals 12, all we need to do is use the slope formula, y2 minus y1 over x2 minus x1. So here we can just plug in the points and get 12 minus 3 over 12 minus 6 equals 9 over 6, which means that the average velocity is 3 over 2 feet per second. This is also the slope of the secant line. So to find the equation of the secant line, we can just plug in 3 over 2 for m and y equals mx plus b and get y equals 3 over 2x plus b, and then plug in the first point and get 3 equals 3 over 2 times 6 plus b, which is 3 equals 9 plus b, and b equals negative 6. So the equation of the secant line is y equals 3 over 2x minus 6. So for instantaneous velocity, however, we are trying to find the velocity at one point instead of between 2 points. This means we cannot use the slope equation. Since we are trying to find the slope of the curve at one point, p, this is equal to the derivative of the function at point p. This means we can use the definition of a derivative or the limit definition to find the instantaneous velocity. Looking at it a different way, if we find the average slope of point r to z, as these points get closer and closer to p, the average slope gets closer and closer to the instantaneous velocity. So we can use the limit definition, limit as h approaches 0 of f of x plus h minus f of x over h. Look familiar? This is also the slope of the tangent line. So, looking at the example problem, we want to find the instantaneous velocity of the function 5x squared plus 4x plus 6 when x equals 8. So we can use the limit definition, limit as h approaches 0 of f of x plus h minus f of x over h. So, when we plug in the function, we get limit as h approaches 0 of 5 times x plus h squared plus 4 times x plus h plus 6 minus 5x squared plus 4x plus 6 over h. So as we distribute and cancel out, we get the limit as h approaches 0 of 10x plus 5h plus 4. And then when we plug in x for 8 for x, and 0 for h, we get 84 feet per second squared, which is the instantaneous velocity. So I hope this video helped you out with finding the tangent line or velocity.